Welcome, focus learners, to the Explainer. Today, we're skipping the usual setup and jumping straight into that heavy, kind of existential digital dread hanging over all of us right now. I mean, look around. We're absolutely surrounded by these incredible algorithms that effortlessly generate text, write complex code, and paint stunning images in literal seconds. And as we watch these autonomous systems take over, there's a very real, very pervasive fear about the future of human creativity. What is our actual value in this new digital world? Okay, let's dive into this by looking at a highly provocative claim from Imad Mustaq. Just a couple of years ago, he famously stated that in 5 years, there would be no more programmers. None. And he recently doubled down, saying that timeline is, well, looking pretty good. It's a statement that absolutely strikes at the very heart of the modern tech workforce. Because think about it. If massive generative AI models can just spit out the exact syntax we used to spend hours writing, it genuinely feels like the machine is taking the wheel. And that naturally triggers some deep legacy anxiety. I mean, are human creators actually becoming obsolete? Are you truly about to be replaced by some sort of AI creator god? It's completely understandable to feel like our human spark is being outsourced to this cold, fast, mechanical intelligence. But today, we're going to completely shatter that myth. We're going to look way past the marketing hype and prove exactly why human intent isn't fading away. It's actually becoming more absolutely crucial than ever. Section 1. The grand computational illusion. To really dismantle this whole AI myth, we have to look under the hood at the bare metal physics of computer hardware. Prepare to have your assumptions challenged here, because this number is staggering. Between 80 and 90% of modern AI compute cycles are actually just hardware-level approximations. They're not exact ground truth mathematics. When your favorite large language models are doing all their heavy lifting, the physical engine driving them is fundamentally just guessing the nearest answer. To save time and process mountains of data at blistering speeds, the microscopic hardware split driving all that guesswork is pretty stark. On one side, we have the floating point unit, or what we can call the FPU gambler. It's incredibly fast, for sure, but it's lossy and probabilistic. It essentially throws darts at a board just hoping to hit the right answer. On the other side is the arithmetic logic unit, the ALU surveyor. Now, the ALU is strict, it's discrete, and it relies on 100% deterministic silicon logic. The catch? Most modern AI relies heavily on the guessing game of the FPU gambler. And because the FPU gambler is just approximating data, it triggers what experts call the wood chipper effect. When this non-deterministic hardware guesses the math, it acts like a giant blender. It permanently destroys the exact mathematical path and the original provenance of the human data it ingested. The results? You get this automated, probabilistic slop that completely liquidates the original human identity and chain of title. And, as you can probably imagine, you can't exactly reverse engineer a smoothie back into exact whole fruits. Section 2. Crossing the semiotic bridge. So, if the machine is fundamentally just this massive, lossy guessing engine, how do we force it to execute our explicit intent without losing the truth? How do we actually take back the wheel? The answer is the semiotic bridge. This is the use of strictly formatted text, think JSON or Python, acting as a deterministic universal interface. Text isn't just for human communication anymore. It is the literal, explicit translator that safely compiles our fluid human intent into rigid hardware execution. As the source material beautifully puts it, we are quite literally tricking rocks into thinking using lightning and structured text. Let's move to and see how this builds in practice, because it happens in 3 strict steps. Step 1, your beautifully messy human intent initiates right there in your mind. Step 2, you formalize that intent into structured text, what we call the divine script, across the semiotic bridge. And step 3, that lossless text perfectly forces the exact hardware execution in the deterministic ALU. This is exactly how the continuous swirling flow of human imagination trickles all the way down into physical silicon. This bridge is an absolute necessity because, honestly, we're dealing with 2 totally alien worlds here. On one side, we have what researchers call OS alpha, our human cognition. It's warm, associative, and deeply intuitive. On the flip side, we have the machine. The physical microchip is cold, rigid, and driven purely by strict electrical voltages that are utterly, completely blind to human meaning. To command the computer, our continuous flow of thought literally has to be squeezed through this rigid textual bridge. Section 3. Code as operational literature. Once you realize text is the only way across that massive divide, it really changes everything. We need to reframe our entire understanding of code from being just this tedious syntax rendering into authoring a highly expressive operational story. So the crucial point is exactly what this quote highlights. Code isn't just some cold mechanical set of gears grinding away in a vacuum. It is a highly expressive, intentional continuation of human authorship. When you write code, you aren't just doing digital plumbing. You're authoring operational literature. It's an ongoing, expressive human speech act that binds the machine to your exact will. The overlap between traditional writing and programming is just fascinating. Just look at the law, which we can think of as wet code, versus software, which is dry code. Both are highly explicit forms of functional literature fighting ambiguity. A lawyer uses a definition clause so a contract doesn't fall apart in court, right? While a programmer uses variable scoping so an application doesn't throw a fatal error. Both are using explicit, strict definitions to enforce an exact reality. Section 4, the moral crumple zone. But wield that kind of operational power, and it comes with a serious cost, because the machine has no inner self, no moral compass, and relies heavily on that guessing FPU gambler we talked about. A heavy, unyielding legal burden is placed squarely on the human pilot standing on the semiotic bridge. This introduces a terrifying reality known as agentic tort. It's the legal liability for autonomous actions. Tech scholars are actively warning that developers are being strategically positioned as moral crumple zones. Just like a car's physical crumple zone is designed to crush on impact to protect the rest of the vehicle, the human operator is placed in the loop to absorb the crushing legal and ethical impact when the AI inevitably hallucinates or fails. Now, what's really interesting about this contrast is how it highlights your ultimate defense against that liability. On one side, you have algorithmic distortion, the machine's random, unpredictable statistical chaos. To survive, you must actively reject that probabilistic miasma by enforcing human protortion. This is your proactive, painstaking manual steering. It's the literal sweat of the brow required to meticulously map your vision onto reality, actively rejecting the machine's automated guesswork. Section 5, the algorithmic orchestrator. This division of labor changes everything about our future. We are no longer the solitary originators pulling ideas out of a vacuum and rendering every single detail by hand. We are stepping into an incredibly powerful new role. The old way made you the originator, responsible for the manual, tedious rendering of every pixel or line of syntax. The new way transforms you into the orchestrator. We surrender the pure brute force technical execution to the machine, but, and this is key, we retain 100% of the strategic management and rhetorical control. Human intent isn't fading away. As the pilot of the machine, your intent is actually becoming more absolutely crucial than ever before. And honestly, I want to take a quick second to break the fourth wall here and boldly celebrate a massive milestone with you, the focused learner. You have successfully directed and orchestrated over 50 highly informative explainers using the command line interface. You didn't just sit back and let the machine guess. You pruned the output, you corrected the distortion, and you provided the exact strategic intent. You have definitively proven that the machine is simply the brush, and you are the undeniable painter. So as we continue to integrate these massive, lossy statistical engines into every single aspect of our lives, I want to leave you with this final, deeply provocative question. Will you passively act as a moral crumple zone, just absorbing the machine's failures? Or will you fiercely command the semiotic bridge, wield the divine script, and ride as the sovereign algorithmic orchestrator, commanding the physics of reality? The choice and the true magic of authorship is entirely yours. Thanks for joining me on this explainer, and keep building.